In this video, I'm going to do a quick review of the exponent rules that you learned in an algebra class. So let's start with one of the easiest exponent rules, and that would be the zero exponent. So by zero exponent, I mean that we have some variable, let's just say x, raised to the 0 power. Well, anything raised to the 0 power is equal to 1. And that is pretty much it for the zero exponent rule. Anytime you have any variable and it's raised to the 0 power, it can always be set equal to 1. The next one I want to go over will be negative exponents. Now, negative exponents will come up in calculus quite frequently as you are simplifying derivatives. And the basic rule is if you have a variable, let's say x, and it's raised to some negative a power, then we can simply rewrite this as 1 over x to the positive a power. An example of this would be x to the negative 3. We can rewrite this as 1 over x to the positive 3. Another version of this would be what happens if we have a variable in the denominator and it's negative. Well, that could be rewritten as x to the positive a. As an example, 1 over x to the negative 2 could be rewritten as x to the positive 2. The key thing to remember here is that if you start off and you have a negative exponent in the numerator, okay, because remember this could be just written as over 1, then you can make it a positive exponent in the denominator. If you start with a negative exponent in the denominator, you can make it a positive exponent in the numerator. So let's just do a couple more with this rule. So if we have z to the negative 2, we can rewrite this as 1 over z squared. If we have 2 over y to the negative 3, we can rewrite this as 2 times y cubed. Now notice the 2 does not move. It is just a constant. It has no relationship with this variable in the exponent at all, so it just stays right where it is. Just as though if we had something like 2 z to the negative 5, again, the 2 has no relationship to the z to the negative 5, so it just stays in the numerator. The z goes down to the denominator, and we raise it to the positive 5 power. Well, what if we have something in the numerator, like x to the negative 2, and we also have y to the negative 3 in the denominator? Well, we can simply think of this as x to the negative 2 over 1 times 1 over y to the negative 3. Because y to the negative 3 is in the denominator, x to the negative 2 is in the numerator. I'm just separating them into two fractions being multiplied together. And you should be able to see that these two fractions multiplied together would give us the original fraction. Well, x to the negative 2 can then be rewritten as 1 over x squared. And 1 over y to the negative 3 can be written as y to the positive 3 over 1, which then multiplying these, we get y cubed over x squared. All right, let's move on to the rule for multiplying bases. If we are multiplying bases, we add the exponents. So as an example, if we have x squared times x to the third, we simply add the exponents. So that would be x to the 2 plus 3, or x to the 5th power. And the reason for this is x squared is really x times x, and that's being multiplied by x cubed, which is really x times x times x. So when we're multiplying all these x's together, how many x's do we really have? We have 5 of them, so we would write it as x to the 5th. But the shortcut is, if the bases are the same, we simply add the exponents. So therefore, if we have a to the 7th times a to the 3rd, and we're multiplying them, we have a to the 10th. Or if we have z to the negative 2 times z to the 5th. Now, we could rewrite the z to the negative 2 as 1 over z squared, but I'm not going to do that. I'm just going to apply this rule, and we would add the exponents, and we have negative 2 plus 5 is 3. And the last rule we want to go over is for dividing bases. If we divide bases, when dividing bases, and of course I mean similar bases, they have the same variable, we subtract the exponents. So as an example, if we have x to the 5th divided by x squared, well, we're dividing the x's. The x is the base, so we subtract the exponents. X to the 5 minus 2 is x cubed. And the reason for this is x to the 5th really means that we have 5 x's in the numerator. Oops, that's 6. And in the denominator, we have 2 x's. And so we can cancel out some of these x's. And what we really left with is our 3 x's in the numerator, or x cubed. And so there's a real quick verification of why this rule works. So just a couple more examples. Let's say we have q to the 7th divided by q to the 4th. That would be q to the 7 minus 4, or q cubed. Now this applies also if we have negative exponents. If we had q to the negative 3 over q to the negative 4. Well, using this rule, we would have q to the negative 3 minus a negative 4, which would be negative 3 plus 4, which is 1. So this is q to the 1st power. Now, you may be thinking, well, couldn't I rewrite this without the negative exponents? And the answer is yes, but you don't need to. All we need to do is follow the rule for dividing the similar bases. But if you wanted to, you could rewrite this as q to the positive 4 divided by q to the positive 3, and the result would be the same. So let's do some exercises. I'm going to put a few exercises on here, and as always, stop the video and try them out and then check and see how you did. So first of all, let's just say we have x to the 7th times x to the negative 3, z to the negative 3 divided by z to the negative 5. And let's just put in a couple more. Let's say we have q to the negative 2 times q to the 5th over q to the negative 4. And then the last one I'm going to do is, let's say we have b to the 5th divided by b to the 5th. All right, stop the video, give these a try, and then see how you did. All right, first one here, I am multiplying the bases. So we simply add the exponents. 7 plus a negative 3 would be x to the 4th. The second one is z divided by z's. So we have negative 3 minus a negative 5, which is negative 3 plus 5, so z squared. Or you could rewrite this in terms of positive exponents as z to the 5th over z cubed, which again would give you z squared. In the next one, we have multiplying and dividing, so I'm just going to multiply the bases in the numerator. And so we would get q cubed divided by q to the negative 4. And now I'm dividing bases, so I'm going to subtract the exponents. 3 minus a negative 4 would be 7. And finally, b to the 5th divided by b to the 5th, well, that's b to the 5 minus 5, which is b to the 0. And remember, the very first exponent rule, anything to the 0 power is 1. And that makes sense because we can see that b to the 5th divided by b to the 5th, you learned a long time ago when you learned fractions that anything divided by itself is always equal to 1. One other power rule that comes up in calculus classes occasionally would be the power rule. And so the power rule says that if you have a variable raised to some power, and then that's raised to another power, you would simply multiply the exponents. So we have x to the ab. So as an example, x squared to the 5th power would be x to the 2 times 5 or 10th. If we have b to the negative 3 raised to the 9th power, well, we simply have b to the negative 27th power. 3 times 9, negative 27, which would be 1 over b to the positive 27. And what if we have 2 over b to the negative 3 raised to the negative 2 power? Well, this would give me in the numerator 2 to the negative 2 over, now b to the negative 3 times negative 2 would be b to the 6th. But we don't want to leave 2 to the negative 2 power. We'd want to move that down to the numerator, 2 squared times b to the 6th, which then would be b to the 4. This would give me 1 over 4b to the 6th. All right, so that is a quick review of the important exponent rules. Make sure that you go over the rules in this video and that you can work with these rules effortlessly so that you don't get bogged down in calculus class with the exponent rules. All right, hope this helped.